So that's a flow-based system, and like Kyle was saying, that's really good for sites that really need to know what the volume's coming in. The channel there, converting that back to a flow, and then for a set volume that passes through it, it'll inject the coagulant to treat that volume. And also, like Mark and Kyle was saying, this one here has actually got a separate system set up to it, and that's a pH buffering setup. So it's got a bit of lime in there that'll inject at the same time.
This here, tipping bucket rain gauge, so there's all this data gets fed back to the cloud. I get it on my phone. It's basically got a processor in there that over here, I'll put this under, but there's black. This is the ultrasonic sensor here. One line's the coagulant line, one line's the lime. This is pH and turbidity that we measure on the inflow. And that under, it'll start to read that there's flow. And you'll hear the pumps kick in. And it'll take a while to probably feed down. As long as the noise doesn't take the lines and dry it up. There you go, so that's a coagulant. It's likely the lime, or if they're still using the lime, I'm not sure, should kick in as well. Oh, so what we're measuring when we're coming here, and we're converting basically that depth back to a flow. So it's all built around what you, for those that do hydraulics, I guess it's around your channel shape, what it's aligned with, everything else. So the downside with these systems, or the flow activated, is you need to have some kind of measuring device. It'll either usually be a pipe, could be a weir, could be a channel like this, but you need something formed that this can measure off. Yep, you could put a V-notch weir. Some systems actually can just sit in the bottom of pipes and read them as well. There's a range of different ways to do it. This one's measuring a depth in a trapezoidal channel and converting it to flow.
And Kyle, you touched on, you've got this, what we call a window of opportunity really for the volume of water, what the effective dose rate range is going to be for that volume. So it may range between say 30 to 70 litres per megalitre of runoff. You're still going to get effective treatment. Other sites may have a really small window of opportunity where you've got to get it pretty bang on to say 35 litres per megalitre or parts per million, that you're going to have to get that in there. So a flow-based system is going to give you that accuracy, but downside is they cost more. What we're hopefully trying to get with is a rain-activated system. You've got for those sites with a large window of opportunity, you're making some guesstimates on how much flow is actually going to come into this point. You have a catchment size, you're going to have a runoff coefficient, you're going to have rainfall, catch tray. You're going to make a guess at how much runoff is going to enter there at that particular time.
So this will all be the catchment tray here. So this has been reduced in size. You can make that obviously bigger, smaller, however you like. That's calibrated for your catchment and for what chemical and dose rate you're using. If you guys go into Appendix B or GDO5, which is the Auckland guideline, it'll spell you out how to determine those catch tray sizes. This is the same as what the Auckland plywood flock sheds that you guys have probably seen a few times. We've just brought it out here to show you basically what's inside it, because it's exactly the same to the flock shed, but this is what you, or how much rainfall you capture. Then comes into what they call a header tank. And the header tank is basically saying if you had 40 mils of rain in the first 10 millimetres, you're unlikely to get runoff. It'll fill up that tank first, and you have some holes that are located in the side here before it will start to overtop. So it's really just taking out that first portion of the rainfall that won't actually produce runoff. Once it tops out, heads into there, it's the bucket in the bucket. So this main holding cell down here is going to have your flock or your coagulant in it. The rainfall is going to move into this. As that pushes down, it's going to push the flock up and out through the tube. It's really simple, pretty ingenious, I think, invention in terms of how it works. But they're the components to it. Header tank, holding tank, and the bucket in the bucket.
What do you fill it with?
You fill the bottom tank up, you reset, so you tip out and so there's management and maintenance with these devices. Obviously you're going to be limited to the volume of the product that you're using. So in this case, this is a 75 litre setup, but you're not going to get a full 75 litre. There's space all around, there's 20 litres there you're not going to get. So you really only got about 50 litres of potential coagulant to use. So you've got to, at part of the process of choosing what product you're going to use, you've got to work what is going to get you those water quality results that you need to get in that time frame. But you also need to work out the practicality of applying that product. So if you're needing a product that needs 300 litres per megalitre for a treatment, say, you're not going to get much out of a system like this.
So the smaller the dose rate, to put it simple, the bigger the area this will treat. This is only a small one of these. You can get these, obviously they're bigger, but you're going to be limited. If you've got something that needs a really, really high dose rate, you're either going to need lots of these, or you may have to move to a flow activated system.
The other limitation with the rain activated system is especially in southeast Queensland, we get these scuds that come through in summer, and this site in particular, big catchment, we'll get rainfall over the back end of the catchment up there and nothing here. So if you don't get anything over the top of this, which is representative of the overall catchment, you know, it's thinking it's dry, you're not displacing anything, but there's a bucket load of water coming down the side. So you've got to limit the catchment sizes for them. And
you could have vice versa too, could you?
Absolutely, you could be injecting a whole lot more just here and you're not getting the volume because it's all dry over there.
They're going to treat up to that sort of 4 to 5 hectare mark. Once you start getting bigger sites, maybe it's best to have 2 basins, or maybe it's best to, if you've got 10 hectares going down to an end-of-line structure, you probably want to know that end-of-line structure is very accurate and you might jump up in scale.
Correct. Or if that window of opportunity is really quite tight for the products, then you need to make sure you're getting a system that's going to measure that flow as best it can to dose accordingly.
These are, it's all going to be risk-based. Smaller sites, lower risk. Simple, smart, cheaper systems are going to be the go. If you've got a very sensitive site, bigger site, you're probably going to have more money to play with to put in a more sophisticated system.